I guess it's official. The Mount Baker Amateur Radio Club Digital Group meeting has begun. We've got a few faces here. We've got Rob running over to see if people are on the wrong Zoom meeting, and we'll bring them back over here. We've got a couple things on the agenda today, not a lot, but we can certainly add more if anybody has something.
Go on. Get.
So we're gonna do an update on the Watchdog timer project, and Steve, did you have two things? But we were going to talk about Direwolf and this other computer. If you're talking, you're muted, Steve.
I have to pay attention to the red slash on the microphone, don't I?
Yeah.
I want to talk about the pulse audio delay and the kernel bug that's affecting some users. And I also want to mention, I think for the second time, this small form factor PC that I found as an alternative to the now very expensive Raspberry Pi. And I think that's it.
Okay. Andy, I know you have to leave early. Do you have anything you want to contribute about any of the stations that are on the air or anything? You're just fine.
No, I've been neglecting them. There is some maintenance that needs to be done. The majority of them are working. The SAR building was down. Steve was very gracious and got that up and working. Again, needed a little poke. And then mine at the house currently, I've got it partway back, but it's sick. It fell victim to that, I guess, described as kernel issue.
Kernel bug, yeah.
Mm-hmm. Bug, yeah. And Steve gave me some directions, but I'm on week 3 of nonstop on the road. So I will tackle that as soon as I get an opportunity. Otherwise, the other machines that I know of are up and running and operational.
Well, that's great. You do have a bandwidth problem tonight, so we won't expect you to pontificate a lot. So it's interesting. You get a little tiny picture, and Steve gets a big one. So, Rob, did you see anybody at the other site? Oh, good. Okay. Well, that's fine. We got a small group. As I've said before the meeting, I've come down with a cold and I'm coughing a lot. So I'm going to try to jump in here, say a few things very quickly, and then pass it on to the rest of the presenters. I have sent off a third printed circuit board to be made. So it'll be the third version of the Watchdog timer. And this is what it looks like. Are you seeing that on your screen?
Yep.
Yeah. So I'm using a new program, it's new to me, called EasyEDA to lay out and design printed circuit boards, and it works really slick. And there's a bit of a learning curve, but I'm getting through it. And then there's some features that it'll do that are really good. You start by laying out a schematic, and I chose to break up all of the various segments of the project into their own boxes here. So we have the timer. We have 2 timers. The initial timer, which is providing a window that the heartbeat has to appear in, and then we have a second timer that determines how long we are going to remove the power from our Nexus stack to do a shutdown and restart. And so they're basically the same, but I'll show you on the board here in a minute. I put 2 resistors in on this one with a jumper so that for test purposes, you don't have to wait 33 seconds for something to happen. If you want to see, be sure that everything is going. And then we lay out the board, and it provides me like photos of this, but this one's cool. Not every part is represented, but most of the parts that are on the board can be rendered in 3D here. So you get a sense of a feel for what it is you're building and what it's going to look like when you get it. So the heart of the Watchdog is this chip right here, which is 2 timers, and these components over here, this capacitor and either of these 2 resistors and a diode determine the initial time slot, and then this capacitor and resistor and diode on this side determine the other time slot. This header right here will actually be an angled header, and there'll be a jumper on there, so you'll be able to switch it between 33 seconds and around 5 seconds. The push buttons that you see down here are optional items. They don't even have to be installed, but it gives you a chance to experiment and troubleshoot and see what's going on on the bench, what's going on. There's no 3D image for these 2 screw terminals. They're identical. One of them is an alternate source for bringing 12 volts into the project, and or you can use a barrel connector here. They do the same thing. And then I'm using a screw terminal for the output, because it's really easy to take it and put a barrel plug on it and plug it into the Nexus stack. So that's how that's going to work. And if we go back to the printed circuit board here, you can see that the wide traces right here are handling the power that's going to the Nexus and the Raspberry Pi. And so it comes in through either of these 2 places. You don't see it on the underneath side of the board, but it goes over to this center pin here. And the relay is wired in its normally closed position so that the power, the 12 volts, is going through the relay straight back to the Nexus stack. Doesn't matter what anything else is doing, your Raspberry Pi is going to be on. Okay, until something starts happening with our windows and our timers, and it becomes necessary to turn the power off for 10 seconds and then turn it back on again. I have 2 ways here to bring our trigger in. I've marked the trigger pin with these dots. I'm experimenting here with a JST connector, and this would require that you actually solder the other end of the connector. There's 3 pins there. 3 wires would be soldered to the Nexus board. We're going to take the TRRS jack off of the Nexus board and use those 4 pins to get what we need back here. The alternate way of doing it is these will be angled headers here and a ribbon cable. I have these 10 centimeter cables. We'll go on here and go up to the TRRS pins on the Nexus board. So we have 2 ways of hooking it up. What else? Oh, I can share what, that's this guy, I think. It's this one probably, yeah. So this is a screen capture of my oscilloscope, and it shows how it's working. The blue line is the trigger. There's going to be a heartbeat coming from the Raspberry Pi, and as long as it keeps coming, everything will just keep running. But if the heartbeat stops, and here I have it set for a little over 10, like 7.5 seconds here. This is in the test mode, where as opposed to 30 seconds. If it doesn't get a heartbeat, then it turns on a transistor which activates the relay, and when this goes high, we shut the power off of our stack. And the good news about that is this shuts everything down except for the timer, the Watchdog. And that means that we now have a way of remotely powering down the sound card, the PPI sound card. Because if even if you have remote control over the Raspberry Pi and you go in and you want to do a restart, you are not restarting the sound card. And there are times when that codec gets twisted up and we need to reboot it. And this will allow us to do that. So that's good. I'll show you one other. Remember to go backwards. This kind of demonstrates what it would look like if we have a heartbeat coming. So as soon as the first heartbeat comes on, this is, I'm reading the timing capacitor. The timing capacitor discharges and then it starts to charge back up again. And every time a heartbeat comes on, it discharges that capacitor again. So each of these heartbeats will start the timing circuit over again. And if I stop giving it the heartbeat, the capacitor continues to charge. And when it gets to being 70% charge, boom, it goes over and it activates the second timer, which is going to energize the coil and shut the power off. And the power will be off, in this case here, for about 10 seconds. Each of these squares is 2.5 seconds. And so that 10-second window will be power down and power back up again. And so that's that in a nutshell. One of the things that we're doing, as far as, I get this window out of my way so I can get back to Zoom. One of the things that we're doing as far as the Raspberry Pi and the timing, there is an internal Watchdog timer in the Raspberry Pi, and Steve can speak better to that than I can. I have seen it happen, particularly with an RMS gateway, when I'm looking over and I'm going, why is my Raspberry Pi restarting itself? It's really obvious when you're connected to it through something like Real VNC, because the whole window goes gray, and then you got this little spinning cartwheel, and then it comes back on again. And it's the Raspberry Pi has decided to just plain reboot itself. And I'm assuming that's the internal Watchdog timer. And Steve, I'm going to turn this over to him and he can fill in, flesh the whole thing in. But we want to give the Raspberry Pi the opportunity to correct its own mistakes. So the Watchdog is going to wait 30 seconds. And if the Raspberry Pi can't rescue itself in 30 seconds, we're going to pull the plug and start it up again. That's what we're thinking here. And the good news is that there's virtually no draw on the Watchdog timer isn't drawing any significant amount of current at all. The original circuit that I started with ran on 5 volts, and the guy used a supercapacitor because he's turning the power off and his 5 volts is going to go away. So he put a supercapacitor in there to keep 5 volts running the timers while things are being shut off and back on again. And I looked at the data sheet on the timer chip, and it said it would run on 5, 10, or 15 volts. So I'm going, I don't need that. I can just go ahead and we can put 13.8 volts into the Watchdog, and we'll keep the Watchdog running while we shut everything else off. And so the first board that I ordered had the supercapacitor on it, and I played around with jumper wires and whatnot and tested the theory of using the main power supply, and that seemed to work fine. And then the second boards came in, and I wrestled with those, and I couldn't figure out why it wasn't working until it dawned on me that I had the first board was working, and I pulled the chip out of it and moved it over to the second board, and it worked. So somewhere I had zapped my chip, and so that's going good. And then the last thing was revelation that occurred to me just at the last minute, and that is it's probably not a good idea to put 13.8 volts to backfeed that into a GPIO pin on a Raspberry Pi. So I said, okay, we're going to put another transistor in there, and basically duplicated the circuit. It's the same circuit that runs the relay. It's going to take care of the heartbeat for us. So we have 5 volts knocking on the door of a transistor, and the transistor is going to handle the falling edge that we need for the timers. And Steve, do you want to shed any light on these timers and internal timers and external timers? Or?
Sure. Yeah, the Watchdog timer that comes as part of the operating system. It's part of the Linux operating system. I may get this wrong because I've forgotten a lot of the details, but every time there's a clock cycle, it updates a register in the Raspberry Pi. So every time a command flows through the CPU, which is every clock cycle, it updates a register. And so this piece of software exists in the Raspberry Pi that says, if I don't see that register updated in X number of seconds, I'm going to reboot. And so the default is 15 seconds, I believe. And Bud and I had a chat about it, and we talked about knocking it down to 10 seconds, and that's configurable in a file in the operating system. It's very easy to change. So we changed it to 10 seconds with the understanding that we're going to give the Watchdog timer that's part of the operating system a chance to recover the Pi first, as Bud said earlier. And so if it gets locked up and 10 seconds go by and it reboots the Pi, that will give it 20 seconds to fully come back up and start generating pulses again to cancel the hardware timer that Bud just talked about. So it won't, power cycle it after a software reboot. On the other hand, if it attempts to reboot the Pi and the Pi is so far gone that the reboot command doesn't work, then the circuit that Bud talked about actually kicks in then 20 seconds or so later, and the power is removed and then reapplied. So it's actually pretty slick. The pulse is going to be driven by the pulse that we're feeding to the circuit that Bud has designed here is the LED output of the shutdown button that you already have on your Nexus. So once this is available, I'll send an update out in the Raspberry Pi under the Nexus utilities that will install a new shutdown button script. So the shutdown button will still work the same as it always has, except that in the normal state, when the Raspberry Pi is on, you'll see a brief pulse of that green LED every couple of seconds. It'll only pulse for about a millisecond. So that will be the only visual change in the Nexus when this is ultimately implemented. So that pulse activates this LED, and then the output that's configured as an output pin because it's driving an LED, and that's the pin that Bud will tap to drive his timer circuit to look for that falling edge that will that if it disappears, if the repeated falling edge disappears, will cause his circuit to activate and remove power from the Pi.
There is a caveat to this, Steve, and that is if you are if you normally use either the button, the reset button on the Nexus board, or you go into the Raspberry Pi menu and say log off, and you want to shut your Raspberry Pi down. The Watchdog timer is going to turn it back on within 20 seconds or so. 30 seconds. It's coming back on. You can't turn it off. It's coming back on. So you will need to get used to the idea that, okay, I shut this thing down. Now I got to reach over and pull the plug, because the Watchdog timer just knows, hey, the heartbeat is gone. I'm going to reboot this thing. So that'll catch some of us, I'm sure.
I'm sure. Yeah, you'll have to remember to physically remove the power after you shut down. But I think most people will get used to that, and ultimately this thing is really going to be useful in locations where there is nobody nearby the Pi. We want it to be like up on a mountain somewhere. We don't want the thing to lock up. So this is, there's nobody there to remove the power anyway.
Yeah, we're I'm losing my train of thought on that. Yeah, just let it go. I'm on meds for this cold. But
Okay. Anything else on the timer, Bud?
oh, I know what it was. I was going to say that anyone who runs a station 24/7 that feels a need to have it kick itself back to life again would be a candidate for the hardware Watchdog. But most of you probably don't need it. It's a lot of people only turn their Nexus on when they want to get on the air, and they turn it off when they're not on the air. You don't need it. But if you're running a gateway, or if you're running a RMS gateway, or a digipeater, fill-in digipeater, any of those things that run continuously, you might want to build one of these. It's looking like it's going to be fairly inexpensive. So when I've been pricing out the parts, I did notice that I forgot to include the brass standoffs. So that'll add a couple dollars to the price. But so, friends and family, we're talking maybe $12 worth of stuff, and we'll make them available once we've had a chance to test it. And you want to build them, yeah. So
Great. Yeah, this is going to be very useful. So thank you, Bud, for.
Well, I've had an opportunity to
doing the work
learn new things, and it's just been great researching these things and making these. That IC chip is just full of all these little AND gates and NAND gates and all these cool little things that do stuff, and they package it up, and all we have to do is they give you got two inputs, which is you have your choice of using either a falling edge or a rising edge, and you have two outputs, so you can have it. Your output could go high, it's called Q, and the other one is called not Q, and they are always the opposite of each other. So if one's high, the other one's low, and if one's low, the other one's high, and then it requires a capacitor and a resistor as a timing circuit, and the math on that is just straight math right off of your technician amateur radio license exam, where you can calculate how many seconds it's going to take to charge this capacitor. And because of the value that we're using for the capacitor, all you have to do is look at the value of the resistor. So if it's 33K, you just take the 33 and you move the decimal point to the left one notch, and you change the K to seconds. It's that simple. And so 330 ohm, a 330K ohm resistor should give us 33 seconds. So anyway, any questions on that before we change the subject? Great.
Rob, go ahead.
Yeah, I was just wondering, your design software, Was there a reason you chose that one, or I know there's others like Eagle, but they're I think paid now, and Fritzing and probably paid. Okay, so is there a reason for a choice on that design, PC board design stuff?
Yeah. The biggest driving force on that was I wanted to use the exact same footprint as the Raspberry Pi. And
Okay.
I'm not able to do that with Fritzing. I would have to, and if you look, for example, at the Nexus board itself, I had to create that footprint myself, and it's got sharp corners. And I'm pretty sure there's a way to do round corners in Fritzing, but it was too much work. And I was able to just go in and literally copy the footprint of a Raspberry Pi and paste it on. And all the holes are in the right spot and all the corners are the right radius, and there it is. And when it came time to order this board, it was so easy. All I had to do is go in the menu. It said fabricate, and it said send it to be built, order it. And I clicked, and a browser window opened up next to me, and there was my board, all in beautiful living color, on their website. And it says, pick what color you want the PCB to be, and click here to pay. And
Okay. How's the
Just getting started or wrapped up?
It's getting started.
Just getting started?
I'll get that one.
Nice.
That's what I hear.
Nice.
Okay. Andy's muted. Well, Steve, we got you down. Oh, before we go, Mark, you have just a simple update for us on the Treasury?
Yeah, there was no business last month.
Yeah. More of the same.
More of the same.
Yeah. Okay, well, we got you down for like 3 different topics here, Steve, and it's always great to hear from you. So why don't you start with whichever one you want to go with first?
Okay, well, I'm going to add a 4th topic, and that is I want to give a shout out to David N7NTN for helping me diagnose just a frustrating problem in the race condition that we sometimes get into when certain packages are updated in the Raspbian operating system that interfere with the AX25 library that we use. And so he took very painstaking steps to document everything he did in order. And that was a tremendous help to me in coming up with a workaround for it so that we can reliably update the operating system and not have it interfere with the AX25 software or vice versa. So I think we've got that problem now solved, and so I just wanted to thank David for his help in getting that resolved. Second thing is the related to the AX25 software that's in the Raspberry Pi. Sometime after March of 2022, a bug was introduced into the kernel that is causing all kinds of problems with folks who are running Linux AX25 gateways, not just for the Raspberry Pi, but any Linux software operating system that's running the RMS gateway software, which is for WinLink, by the way. The problem is that a station running PAT or WinLink on a PC, for example, if they connect to one of these affected RMS gateways, they get a successful connection and all works as expected, and then they disconnect. They can no longer connect to that same station. They can't connect a second time to it. It won't allow it. Now, if another station, another WinLink station, for example, connects to that same RMS gateway, then that first station who was having trouble can now connect to that station, that RMS gateway station. But that second WinLink client now can't. I know it's really convoluted and difficult to understand. But anyway, it's causing a lot of problems. There's a simple workaround, and that is to install the kernel that's dated March 31st, 2022, and then set up your Raspberry Pi to say, use this kernel, and if another kernel comes along and that's available for updating, ignore it. There's a way to, just four commands that you put in to get that fixed. That only affects stations that are running the RMS gateway software, which is very few. So it doesn't really affect the average ham user. However, the same bug also affects clients using this software. So some of you may have noticed, if you're running the TNC manager, for example, on the Nexus, and you connect to a station, whether it be a Windows RMS gateway or a Linux RMS gateway, it doesn't matter. If you're using the TNC manager, which uses Direwolf and PAT, for example, you will find that you cannot connect a second time to that WinLink gateway that you just connected to successfully. The workaround there is the same fix that I described earlier. However, when you're running the client, which the TNC manager is, all you need to do is hit restart in the TNC manager, which restarts the whole thing. And then you can connect again to that WinLink manager. Unless, of course, the RMS gateway that you're connecting to is also affected by this bug. So I've fixed the ones that were affected in Whatcom County. So you shouldn't encounter it with any of the RMS gateways in Whatcom County that I control anyway. And the ones that are running Windows RMS gateway software are not affected by this bug. So this is an ongoing problem. The fellow who maintains the RMS gateway software, Budd, and I know him, and he's been researching this and is has been testing various kernels. There are some newer kernels that have a fix in it, but that fix has not yet been rolled into the Raspberry Pi kernel. And it could be months before this is addressed in the Raspberry Pi. Second thing, as some of you may know, the Raspberry Pi image that we use with the Nexus DRX uses the pulse audio system to easily separate the left and right channels of the FPI card, so you can run two radios or two instances of FLDigi, for example, at the same time. I have noticed that when you're running pulse audio, and especially with Direwolf, that there's an audio delay. So when push to talk is activated, there's a second or so of silence before the audio is sent from the Raspberry Pi to the radio. And I would appreciate it if you folks could test it, both with FLDigi, whatever mode you use, with PAT, with the TNC manager and Direwolf, that's, whatever application you use, WSJTX, whatever it is, and see if you can notice this delay. I've noticed it in FLDigi, although it doesn't seem to be as pronounced or long in FLDigi, but it's around a second for Direwolf when connecting to another packet station, like an RMS gateway. So I'd appreciate reports. You can post them to the digital group, groups.io, and let me know your experience there. I do have a workaround for it. It's somewhat involved, so I want to make sure I have all my ducks in a row and have the correct information here. Another person has reported this to me, and so I know that at least one other person is experiencing it, but I would like to get other reports from other folks as well. So again, after push to talk is activated, there'll be a moment of silence, like up to a second of silence, and then the Raspberry Pi will send the audio to the radio. So you'll have to have another radio or something monitoring the same frequency so you can detect, you know, push to talk and then when the audio actually appears. So I'd appreciate reports on that. Okay, questions on that? Okay. My last topic is, I think I talked about this earlier, but I want to reiterate because it's such an exceptional deal. I'm going to share my screen here. And I'll do this one here. Okay, so this is a small form factor PC that's available on Amazon. And there are literally dozens of these on Amazon, probably hundreds of these on Amazon. I bought this one back in September, and the current price is around $200, but there's a $30 coupon that brings it down to around $170. When I bought this back in September, I paid around $160 for it. It's a 5-inch by 5-inch by 2.5 inches high, small form factor computer. It's an Intel computer. It has 8 gigabytes of RAM. It has a 256 gigabyte solid state drive in it. And it has quite a fast Intel CPU in it. It comes with Windows 11 Pro. So if you're comfortable with Windows, you know, you're ready to go. You can just install FLDigi and the other software and you know, whatever other software you want to go, and you can be on the air in short order. It doesn't have any kind of sound interface, of course. It's just a PC. So I also mentioned in one of the last meetings, this little guy here, this little Digirig, which is a sound card and a push-to-talk circuit. Okay, so this would serve the role of the Nexus board, if you will, for a computer like the one I'm showing. And this little Digirig, if you buy this with the appropriate cable, although you can make your own cables if you want, you're looking at around $80 for this and the cable. Right now, this is $170 for this guy here. So you know you're talking about you know $250 for a working ham station. The other advantage of this guy here is it operates on 12 volts. So you can plug your battery. That's what I'm doing at home here. I'm just plugging my ham radio power supply right into this PC, and it works great. Runs on 12 volts. Okay. Now you compare that with the latest price of the Raspberry Pi. The 8 gigabyte Raspberry Pi on Amazon is $214. Okay. And if you buy Budd's board and you're not friends and family, you pay $84 for the Nexus board and the FeePi card. So you're looking at what's actually a much more capable computer here with this Digirig sound card for less money than the Raspberry Pi and the Nexus board. Not, you know, I work closely with Budd on the Nexus board, but right now it's really expensive to get a setup with a Raspberry Pi and the Nexus board. So I'm just mentioning this as an alternative. Okay, and I just I just found this one. It seemed to be a good deal, and I know I bought this one. But like I said, there are dozens, if not hundreds, of these small form factor computers on Amazon and other websites.
And Steve, the good news is you don't have to build it.
You do not have to build it. It comes completely assembled. On this particular one, you'll notice that this bottom edge here, you see this line around the bottom edge? This bottom comes off, and you can put a second SSD in there if you want to. It has a USB-C interface, or I'm sorry, a SATA interface in it. So you can just buy an SSD disk drive and slide that in here. Or if you don't want to use it, just remove this base, and then it's only about 1.5 inches high rather than 2.5 inches. And like I said, it runs on 12 volts.
Steve, how difficult is it to put a Linux system on it?
Piece of cake. So it's just an Intel computer, so you can, attach a USB thumb drive, boot from that, and install whatever you want on there. Ubuntu, Red Hat, whatever you want to put on there. It does come with Windows 11 Pro. So if you're already familiar with Windows, you're all set. If you're familiar with Linux, then you probably already know how to install Linux on a PC. So yeah, it's a good deal. And this Digirig little sound card, I have tested this on Raspberry Pi, on Ubuntu Linux, on Windows, on a Mac. It works great on all of them. I didn't have to do any kind of software modification at all on any of those operating systems. It was recognized immediately by all of them. So. Okay, I will post this so we have a little bit of more staying power, I guess. I'll post the link to this website or to this particular PC and to the Digirig on the groups.io. So there's a more permanent record of it there.
Steve, how do you trigger the push to talk with that little box?
Yeah, okay. So you'll notice on one end here, there's a USB interface. Okay, it's a USB-C. And so you plug that into your computer, either a USB-C port or you get a USB-C to USB-A cable and plug it into any USB port on your PC. It presents the sound card interface. So it'll show up like a signal link does, for example, if you're familiar with that. And it creates a COM port on your computer if you're running Windows. Or it'll create a TTY USB 0, 1, or 2 on Linux. And then you go into your FL Digi software and you tell it, I want to activate push to talk on TTY USB 0 if you're running Linux. And you check the request to send box. And that's what this guy does. So when push to talk is sent from the radio, I'm sorry, from the PC to the radio to this box. No, from the from the PC, or if your software is activating push to talk, it brings request to send high, which closes the push to talk contact on this and then sends that onto the radio. This is one of the cables that you can get. So it has a TRRS plug on one side. So there's 4 positions there, and that just plugs into the audio port of the device. And then the other end is the regular mini DIN 6 connector that we all use today on the Nexus card. And the specification, he sells a wide variety of cables. So when you order this from his website, you tell him what radio you have, and then he'll make sure you get the right cable. Or he has schematics for everything too, so you can build your own cables. I built a couple of extra cables myself for this box. It was quite easy to do. Hey, any questions?
I have a question.
Yeah.
So are you hooking that up to your B71 or your, what, you have a D710?
Yes.
And all you need is the one mini DIN, or do you use the programming cable as well?
Don't need the programming cable. No.
Okay.
Yep. All you need is this. You need the programming cable, of course, if you want to do rig control of the 71. But yeah, for push to talk and audio, you just need this one cable, the mini DIN 6.
Okay, so if you had Linux and you did plug in the programming cable, then could you use this the software the same way as you do with the Nexus?
Are you talking about the script I wrote to control the Python script?
I don't think I'm going down a dark hole here. I don't think.
So if you want to use the script that I wrote that runs on the Raspberry Pi that brings up a little GUI image of the TM V71A or the 710, that script will also work on Linux. Okay, it doesn't need to be a Raspberry Pi. You can run it on any Linux operating system. And I think with maybe just a very minor bit of tweaking, probably will work on Windows as well. I know it works on a Mac. So if anyone here is interested in getting that script to work on Windows, let me know, and I'll look into it.
Well, Steve, maybe you could shed some light on why we have to wait months to get a bug fixed in the Raspberry Pi. What is the process? What's going on? Is it all beta testing, or what? Why does it take months?
Well, the kernel itself is a complicated thing, as you can imagine, and there are hundreds, if not thousands, of programmers that contribute to it. And so whenever there's a patch submitted to the kernel, it goes through this vetting process by hundreds, dozens, maybe hundreds of programmers to make sure that, yeah, it does what it's supposed to do. It doesn't break anything else, and then it ultimately ends up in the kernel. So that is the sort of the mother of all kernels that Linus Torvalds blesses. Okay, then that kernel trickles down to all these other distributions like Red Hat and Ubuntu, and all these other companies that manufacture Linux operating systems. And they're probably not on the cutting edge of every kernel release. Okay, so they're producing their own operating systems that are lagging a little bit from what's actually in the very latest kernel, because they're testing and making sure that it works, and that the folks aren't going to encounter a lot of problems with it. So that's another layer of delay. And the Raspberry Pi folks are in that same boat. So they're dependent on the Debian branch of that kernel. So you have Linus Torvalds blessing that particular change. Debian then rolls it into their release, and then the Raspbian folks take that Debian release and then refactor it so that it works with the Raspberry Pi. And so it takes months to get through all of those different layers of validation and checking and so on.
Well, does anybody else have anything for the group tonight? Any questions about stuff that's coming up, or any issues you want to bring up?
I have a question.
Yeah.
On your Smart Heard software, when I open up FSQ and it comes up, it's running a, what's it say, missing operand. It says stat missing operand and it runs in a loop. And I think it's the product of the last update that messed up the stuff that Steve was talking about. That so I'm not sure if there's a way.
Usually there's some sort of a corrupt entry in like the Smart Heard List itself. There's a file that contains all this data. And if you will go into the WB7FHC folder, you will see a folder in there that's called backup. And you can roll that back to an earlier version and see if it goes away. And that's typically what happens, is that we're constantly reading and writing data to text files. And if we try to get people to use escape to shut it down, but sometimes you just, that little exit there in the corner seems convenient. And there's multiple ways to corrupt that file. And that's why you'll find 5 or 6 backups. And just kind of, I would say, pull out one. The file names should be obvious because you're going to see the date in the backup. And it's just a matter of copying the file back into the main WB7FHC folder and giving it the name of the one that we're using. And I think you'll be okay.
Okay, I'm looking at the list now, so mine goes back to 11.8.
So one thing you can tell is, like, if you go ahead and open the Smart Heard list, and you'll see that everything seems to be in a certain pattern, and then you'll have like one line that's screwed up, and that's your problem. So sometimes you can just delete a line and it starts working again. So
Okay, I'll mess around and see if I can wreck everything.
yeah, poke around in there and see if you can resurrect it. But that's usually what causes it.
Thank you.
Anybody else? Well, if not, we could start stacking the chairs. One thing I might bring up, and that is we have off and on talked about having a in-person session on the 5th Tuesday of the month, and we would have to maybe coordinate this with the general group. But on November 29th, of course it's just after Thanksgiving, but there is a 5th Tuesday. And I wonder if there's any interest in, say, everybody that wants to show up at a local pizzeria or something and get some pitchers of beer and eat some pizza and talk. Not have a formal meeting or anything, but just an excuse to get together and not be on Zoom. So, and if you want to bring something to share and show and tell, that'd be fine too. But anybody have any suggestions, ideas? Is it worth pursuing, or is it just too crazy of a month and a week to even deal with it?
Not a good time of year, Bud. Not a good time of year.
Yeah, well, that's what I'm thinking too. So, and I'm not hearing a lot of enthusiastic, yeah, let's do it coming back. So let's not worry about it.
Sounds great, but yeah, I kind of concur that it's just a really busy time.
Yeah, I don't know when the next one is. It might be in March. We can look into it in the future. So we get a week off. For those of us that do something almost every Tuesday night. Yeah. Well, okay then. I think I'll go ahead and
73s, guys. 73s.
pull the plug and start the recording processing, and we'll catch you guys later. Good night, everybody.
Good night.
All right?